In a world filled with war, judgmental people, people who lie to you, try to take advantage of you, and so forth, science becomes this sort of neutralizing point where you can literally go through all these stuff, but on the other hand, you can pick up something scientific, a book, video, article, biography, doesn't matter, and it sort of calms down the mind. And it's amazing that how it has that magical power to do that, even for those people who are not scientific. Even those who have never done research in their lives before, they can go through a lot of BS in this world. And then suddenly they can become introduced to maybe a scientific topic and whatnot, then it just totally shifts their state of being. I've experienced this myself and I've seen it as well. And when I'm talking about science, I'm not talking about the politics of it or people who do it because of their ego and then they have to win awards and all those stuff. Not that. Just take pure science, pure knowledge, pure that thirst we have to, for example, find out, let's say in our case, how the brain works. And it's just this sort of pure, innocent way of looking at things. And those questions, that thirst to figure things out really can come to anybody. They really don't need to have scientific background. I did not have any scientific background from my family, like nobody. In fact, when I picked books, it was like, they would look weird at me. It's like, what are you doing? And it's still, I figured out early on that for some reason, it sort of healed me. It healed my mind because of this. My outside world was extremely chaotic and emotional and chaotic. And I found, this sort of peaceful world in anything remotely scientific. Honestly, I mean, obviously you don't understand much when you read something scientific. I mean, I still don't, but to the extent that I could read. And so it is amazing how you could have those questions, those fundamental questions, and we still do, because there's just so much we know, but there's just so much we don't know. And when you have these scientists who really do something so basic that it's so simple, but then for hundreds of years forward, everybody else is still building up upon that. Those are those fundamental established frameworks that just, it blows my mind away when I think, how is it possible that somebody just could come up with something so trivial, so basic, and then it still can get carried on for years to be built upon. And that's mainly because those are the moments where you are really pure in your mind, and you sort of go with it. You sort of do it. You don't think about you're going to get recognition or get an award or anything like that. You just sort of do it. And then that's one of the main reasons I'm keeping a lot of my thoughts now, and in terms of research, I should say, independent, because I don't really want to be sort of dependent on, let's say, a funding or stuff like that, because I'm afraid that it's going to impact it, influence it. Obviously, the bad part of it is that then it goes really slowly because you don't have funding. But that aside, I wanted to share with you, if you have not heard of Alan Turing, if you're interested, check him out. It blows my mind. When the first time I ever heard of his story, it was just blew my mind away. He was one of the first one who even thought about explaining biological matters in our lives with mathematics. So at his time, nobody even made that connection. Like, can we explain biology with mathematics? And so he did. And one of the reasons he even started thinking about it was because one of his friends, I think, died, and he was just thinking about the mind, something that I'm sure you've thought about as well. Like, what happens when we die? And I'm not talking religious or anything like that. Please, let's put all that aside, but let's just, like, at a scientific point of view, what happens? And he was one of those geniuses who was like thinking about it and then came up with it, and even ended up writing a paper, and that I'm going to show you shortly. But basically, he was explaining he was using mathematics to explain the embryo and how the cells divide, and how potentially they know what to do or where to go. I mean, the moment of the cell starts in an embryo start developing, like, how the F does it know that this is going to be part of the brain, this is going to be part of the nose, and whatever. And it just blows my mind away. And the truth of the matter is that we still don't know, what happens. There's a lot of things, but he actually wrote that paper and made that connection. And that is the basics of a lot of things that we're trying to today answer, at least to some extent, mathematically. And, obviously he was interested in many other things, but, he was very genius. So I want to show you the paper. But before that, I want to show you his Wikipedia page to kind of just read about it a little bit. And the tragical part of this is that allegedly he committed suicide because I say allegedly because some people say that he didn't commit suicide. It was an accident. Some say it was a suicide, but that doesn't matter. The truth of the matter is that he was arrested because I don't know exactly the word they use, exposure of indecency or whatever, but that they gave him that sentence because he was gay. And at that point in time, when he was alive, being gay was not looked good upon, and he was a scholar already, so he took the blame. I should say they blamed him, apparently, because they said that, well, you're a scholar and you're educated and you belong into the scientific community, so you were the one who basically tricked this young guy to be with you. And they gave him a choice of either go to prison or get hormones to be fixed as a gay. So, and then, he shortly after he wrote his paper, one of the most famous paper, he committed suicide. And every time I think about it, I cry. And anyways, so I just get really, I get mad, and I think it's just so cruel. People who are different in this world, they have to go through so much stuff that is just not fair. Anyway, so, but the reason I'm also bringing this topic about Turing is that the more we now learn about his work, the more we realize that if you think about it, he's actually more or less could be considered the father of the theoretical computer science. I mean, theoretical computer science basically is computational neuroscience is part of that as well, because it's theoretical. It's like, you know, you work with, it's not an experimental, you work with it. And also artificial intelligence. So they say that. I'll share this link with you so you can read about his life a little bit if you don't know him already. And I'm sure you do, because he's pretty famous. But this is the paper that I wanted to show you. You may have not seen this, but this is his actual real paper. And I'm so glad that he was actually able to write this. And this is shortly before his death. And so this was written back in, or published back in 1952. So, and the chemical basis of morphogenesis. And here is where he's trying to explain the morphogenesis by using mathematical descriptions to, you know, talk about morphogenesis and looking for the patterns and things like that. I'll put this link also below if you want to read it yourself, but I just wanted to, I'm so thankful that this paper is published. I mean, imagine if this was not published, just Jesus. Anyways, so this is the abstract where he's writing. And I just want to read the abstract to you because then you can read the rest of the paper yourself. I've tried to read it several times, but it's hard for me because, you know, he goes way over my head. But I keep trying. Every time I have some time over, I just look over it. But, you know, maybe you understand it better. I don't know. But it's like, it's really, really interesting. So here's what he says. It is suggested that a system of chemical substances called morphogenesis reacting together and diffusing through a tissue is adequate to account for the main phenomena of morphogenesis. Such a system, although it may originally be quite homogeneous, may later develop a pattern or structure due to an instability of the homogeneous equilibrium, which is triggered off by random disturbances. Such reaction diffusion systems are considered in some detail in the case of an isolated ring of cells, a mathematically convenient, though biologically unusual system. The investigation is chiefly concerned with the onset of instability. It is found that there are 6 essentially different forms which this may take. In the most interesting form, stationary waves appear on the ring. This part blows my mind away, by the way, whenever they say waves, because I think about neural oscillation. So I've actually even searched for waves in the paper. And I've read those paragraphs so many times. It is suggested that this might account, for instance, for the tentacle patterns on hydra and Vohorlet leaves. A system of reaction and diffusion on a sphere is also considered. Such a system appears to account for gastrulation. Another reaction system is 2 dimensions, gives rise to patterns reminiscent of dappling. It is also suggested that stationary waves in 2 dimensions could account for phenomena of phyllotaxis. I have no idea what that is. The purpose of this paper is to discuss a possible mechanism by which the genes of zygote may determine the anatomical structure of the resulting organism. Wow. The theory does not make any new hypothesis. It merely suggests that certain well-known physical laws are sufficient to account for many of the facts. So he's using physical laws as well. The full understanding of the paper requires a good knowledge of mathematics. Yes, true. Some biology and some elementary chemistry. Since readers cannot be expected to be experts in all of these subjects, a number of elementary facts are explained, which can be found in textbooks, but whose omission would make the paper difficult reading. And then he goes on and talks about a model of the embryo, morphogenesis, etc. Anyways, so let me stop sharing. So if you get a chance, read it. It's very interesting. You maybe understand it more than I do, but I just find it very interesting. And in our case, I think it's great that we get more and more people who are interested in learning about the brain. Obviously the whole biology, but I think the brain in this case is so fascinating because apparently, based on what we know so far, it makes this like all these like magical computation. It used the physical aspect of our body in terms of biology and chemistry, let's say neurotransmitters, but it also emanates electricity, neural oscillation, aka brain waves, and all of that. And we still don't know exactly how everything works. And it's just amazing that one moment we're alive and this brain is just so amazing and it can create and talk and laugh and create all these amazing things and think all these amazing thoughts. And then the next moment is just gone. Like it becomes a piece of meat. If you ever watched the TV show Bones, I really like that show. There was one episode I never forget. I mean, you know it theoretically, but seeing it, and you know it's a show, but it's still, they had to take out the brain of one of the victims, and they had to slice it so that they wanted to go into the center of the brain. I don't know which part, I forgot, but to see like, changes or whatever, to kind of, gather evidence to catch the murderer. But this is the part I never forget. You know how you go to Delhi, they have these machines and then they do this to like cut you, piece of meat or whatever to kind of slice it, slice it. They actually use that slicing machine in that episode. And then instead of, obviously whatever, they had the brain on the slicing machine. And they were going like this, and then it showed that at the end, like you had one slice of the brain sort of coming out from the machine. And it was just the most strongest visual I've ever seen, in front of me. And I think if I had seen it in real life, I would probably faint because I'm pretty like lighthearted. But the fact that they kind of slice it, and that moment I thought, Jesus, this piece of meat, like just sliced now on the slider, is just, it used to think, it used to do all these amazing things, and then within half a second, like it's gone. Yeah, I can't imagine. I actually, there is a video I want to do about EEG of death, because recently they published a paper that accidentally they measured a patient's EEG, and right at that moment he died. So they kept they could do post and pre-mortem EEG data. And we have those data from rodents, but never from humans. And it was an 87-year-old man. So obviously it's only one, subject, but it was still very interesting. I read the paper very quickly, but it was a lot of gamma bands apparently shown even after death, a few seconds. So anyways, very interesting. So I hope this was helpful. Just wanted to share with you about Alan Turing and how way back when he's the one who started with computers, and he's sort of the father of even thinking about computers, how computers are made, and communication, information exchanges, and computation. Very interesting. There's, by the way, also a documentary on Prime that with Professor, I can't say his name, Khalili. He makes these shows for BBC. He's a scientist, and he makes these amazing, I love his documentaries. And he also brought up how Turing basically impacted all these sort of computational science and computer world, our modern world of computer, I should put it this way. All right, guys. So I hope you find it useful. Thanks for watching. I'll see you next time. Bye.